So I suppose we can go ahead and get started. They're starting to shut the door back. Oh, here comes someone. Hi, everyone. My name is Scott Harwell. I am the product manager responsible for Ansible Lightspeed, formerly known as Project Wisdom as of yesterday, so apologies if you hear us kind of throwing the name around back and forth, but we mean Ansible Lightspeed with Watson Code Assistant moving forward. I'm joined by Robin Bobbitt, who's one of our senior engineers for Ansible Lightspeed here at Red Hat, and Atin Sud, who's one of his title says data science expert up there, but he kind of a jack of all trades at IBM Research. So we thank you for joining us here. So we wanted to dive a little deeper into Ansible Lightspeed, more so than the keynotes were able to. What we're going to do is share a little bit more about what our objectives are with the effort. So you got, again, kind of a high-level overview of what you can participate in today, but we want to dive a little deeper. Atin is going to talk about machine learning just in general and IBM's processes for building foundation models and how we've collaborated to develop models for Ansible Lightspeed. And then we want to talk about how we've developed this solution for Ansible automators in particular, and then looking forward into the future, what does this mean for the rest of the year, and what sort of additional capabilities can you all look forward to as we continue to develop this product. So again, the keynotes hit on this a little bit, but just to kind of give you a frame of reference for where we started. When we started working with IBM, we started to consider who would really get the most value out of generative AI with Ansible. And there's a lot of different personas in the Ansible space, and we've taken we've done a poor job here on this screen, kind of bucketing people into 4 different categories. One being the automator, and this is typically somebody who's using Ansible Automation Platform, might run an automation, but they really don't have any engagement in writing automation, let alone writing Ansible modules, roles, collections, etc. The content consumer, they might be the person who, I'm sorry, that would be the content consumer. I flip my roles here. The automator would be the person who's writing playbooks, roles, collections, etc. And then leaning into our content developer and module developers, this is just an expanding skill set of technical prowess, basically. So our module developers are going to be those folks who are writing Python and not necessarily modules themselves. And so when we looked at this problem, we really wanted to ask ourselves what type of audience is going to get the most value out of generative AI. They have to understand enough that they can assess the value of what's being delivered to them, but they don't necessarily have to be experts who are going to, who've been writing Ansible automation for 10 years and can, who already know best practices and may not necessarily get anything more out of it than say a templatization system. And so, really our sweet spot was right here in this content consumer and developer space, where organizations who have maybe one Ansible expert, but maybe need to train multiple experts, multiple other automators. Those new automators can leverage a tool like this to come up to speed really quickly, but they still got somebody who can assess the work on the other side of that equation, right? Being able to make sure that whatever playbook or role or collection is being developed has some human eyeballs to review it at the end. We're not entirely trusting AI at this point. And so that's where we got started. It's that content consumer leaning into, or content developer leaning into content consumer, so that the automator can take advantage of ultimately what gets built. And so with that frame of reference in mind, we've partnered with IBM to bring those capabilities into the Ansible experience. And so as we talk about Ansible Lightspeed, think of this as the Ansible experience part of the equation. This is going to be your user interfaces through VS Code that you have right now, any user interface that we develop in the future, APIs, things of that nature. And we're integrating with Watson Code Assistant with our counterparts at IBM to deliver all of the machine learning and data science and capabilities for tuning models and things like that. So with IBM, we've been able to couple these two groups together, bringing kind of best of breed solutions for Ansible automators, and that's what we've been able to present in the keynotes here this week. And now we want to give you a brief look under the hood. So let's talk about some data science. Atin's going to come up. We're going to do another demo. So Robin's going to show something a little bit different than what was shown at the keynotes, but hopefully that can dive into some curiosity from your perspective, and we can do a little QA at the end if you have questions about how it works and why things operate the way that they do. And then we want to talk about what the future looks like. So how do we move this from our preview state that is available for free starting next month into additional value for commercial customers, things of that nature. So we're going to cover all of that today. And so I'd like to throw it over to Atin here to dive under the hood. I'll applaud for you.
Thanks for that introduction, Scott. Okay, good. So let me start with the most fundamental question, right? Like, well, AI has been there for a while, at least 3 decades now, and we have had different flavors of AI. But what is so different now? Like, why are we so excited about, say, ChatGPT or Stability AI? Like, why do we think that this is different? And there's basically 3 components or 3 pillars to it in my mind. Data, like do we have access to a lot of data? Because AI requires a lot of data to train on. AI is basically just patterns. You're trying to look for patterns. The more data that you have, the better you're going to be at understanding the patterns. So the data has been there for a while, like the big data era and ability to sort of have gobs and gobs of data. Compute, the whole cloud computing, cloud as a computer has made it easy for us to get access to a lot of compute readily available to us. So that has been there for a while now. But the third one that's more interesting at this point of time is the foundation models, right? This whole idea with ChatGPT is that you're basically doing what are called foundation models. And the idea is that what used to happen earlier is that if you had 3 problems, say you had to do a text-to-speech, speech-to-text, you had to do some sort of language translation, you used to create individual AI models for each of these things. And that would require experts in each of these fields. And that's the whole idea behind the foundation model. The idea is that if you train a model, a large enough model, on a large enough amount of data, the idea is that the model is able to generalize, right? So for example, if you look at ChatGPT, you can ask it English poetry. You can ask it code-related questions. You can ask it to create a travel itinerary. Like, how is it able to figure out all of these things? And that's the whole idea behind some of these foundation models, that you train a model large enough on large number of training data, and the idea is that the model then generalizes, right? But what does it mean to sort of build out a foundation model with Red Hat, right? So what we sort of started going after is we started working with Red Hat, and we train a large model basically on a lot of natural language data so that the model understands English, because what we're trying to go after is a problem that given a question in English, can you sort of answer that question? So the model has to be trained on English. So the first thing that we started is, well, let's train the model on English. But then the second thing that we did is, well, the model needs to understand Ansible, and what is the best place to understand Ansible? And that's where we worked with Red Hat to train a model on open Ansible data that is available on Galaxy, right? So that's how we sort of went about it. But okay, we did machine learning, we trained the model, but we are not Ansible experts in IBM. Well, we have written somewhat of an Ansible, but we are not Ansible experts. And that was the second value that, to me, the biggest value that Red Hat sort of brings to the table. They understand Ansible better than anyone else, right? So the idea is that we worked with Red Hat to train a large language model on Ansible data with all the experience that Red Hat brought to the table, right? So what does exactly that even means, like training a foundation model? What does training a foundation model means? And this is a very, very, very simplistic view of what the slide should look like. But the idea is that you start from the left side of the equation. So you basically take a bunch of natural language data. You take a bunch of code. The idea is that you possibly scrape this off of internet. You start with this data, and what you try to do is you try to sort of clean up this data, right? Because this data can have a lot of noise. So you start doing deduplication. So you do some basic min hashing, max hashing to basically figure out, okay, is this data duplicate of each other? You try to do hate and profanity filtering, because as you know, internet has some interesting stuff there. So you try to do hate and profanity filtering. You also want to make sure that you're respecting people's choice. So we do the licensing, like, okay, what are the permissive licenses that we can go after? What are the licenses that we shouldn't be using, right? So we basically do what is called data filtering or data preparation on this data. And then this data is ready to train a machine learning model. So I'll go into the details of this, but like the idea is that once you train the machine learning model, then this machine learning model can do a recommendation, it can do attribution, like if given a recommendation, why do I think that this recommendation is the right recommendation? You can do, I gave you a recommendation, you decided to accept it or not. We can do that as a signal, that is a feedback to the model that whether you're doing right or not, right? But what exactly does training a large model even mean in the first place, right? So what a AI model in general is, it's basically a large mathematical equation, right? All you're writing is a really, really large mathematical equation with lots and lots of variables, right? And what you're trying to do is that you're saying that if I want to sort of solve this mathematical equation, what I do is I give it a lot of data, and all I'm going to do is just do curve fitting, right? So if I give it, it's a large equation with lots of variables. I try to fill in those variables with a data point, and then I say whether it solves the problem or not. Then I do it again, and then I do it again, and then I do it again. So that's what training a machine learning model is basically. It's very basic at the core of it. It's very basic matrix calculus followed by differential calculus, right? So it's as dead simple as that. So if you're a high school student, you should be able to sort of get the mathematical concepts behind this. But what are the steps in training a machine learning model, right? So there basically tends to be 2 steps in training a machine learning model. The first one is called pre-training. And what you're doing in pre-training is you're trying to teach the language to the model, right? So say if you're saying, I am a, so you basically tell the model that what you have to do is that if I give you I am a, you have to predict what comes after a, right? So it can be I am a cat, I am a dog, I am a man, right? So that's what you're trying. And that's why these models are called generative models, because they're generating something, right? So the way you train these models is that you take an input. So for example, you can say my input is ensure Apache is at the latest version, and then you say, here's a blank after that, try fill in that blank, right? So what you're trying to fill in the blank is ansible.builtin.yam. So that's what's called pre-training. You're basically trying to teach language to the model or the syntax to the model. So it knows that when it needs to make a prediction, there needs to be a space after this, or there needs to be a new line after this. So you're basically trying to, it's like teaching a child, right? You're basically trying to teach someone what does the syntax of a language look like, right? So that's what you're trying to do in what is called a pre-training, right? So if you look at what we're saying, we're basically saying, here's a YAML sample 1, separator YAML sample 2, separator YAML sample 3, and now try to predict another YAML sample for me, right? So that's what you're basically trying to do. The next step of this is basically what's called a fine-tuning step. And a fine-tuning step is where you're basically saying, I'm going to give you a left-hand side and a right-hand side. So basically, I'm going to say, if the context is this, what's mentioned over here, and if the prompt is basically write an Apache config file, then try to predict what's going to come after that, right? So fine-tuning is more like what is called a supervised learning. So you're basically giving it a right-hand column and a left-hand column, and you're basically giving it hundreds and thousands of examples. So if there are hundreds and thousands of examples, we're trying to say, here's the left-hand side, here's the right-hand side, take the input on the left-hand side, and try to predict the right-hand side. So what you can imagine is that if we have lots and lots of Galaxy data, then we have lots and lots of examples where people are trying to do these kind of patterns, right? People are trying to install packages, or people are trying to update their packages, or people are trying to install EC2 VM instances. So the idea is that once you've shown it enough number of these examples, the model tries to learn what these patterns are going to look like, right? So pre-training generally is a much, much, much longer process. So in our case, when we do pre-training, we're training it on A100s. Those are the GPUs that we train it on. And it almost takes a week for us to sort of train this model on a pre-training set of data. Fine-tuning tends to be much faster because the amount of data that you have is much smaller. So for pre-training, you could imagine that we have picked up a large amount of natural language data. We have picked up a large amount of YAML. We have picked up a large amount of Galaxy data. And we're just trying to pre-train the model. Whereas on fine-tuning, you could imagine that we have basically said that here is a good number of Galaxy data that you basically do a left-hand side and a right-hand side, and you basically try to train the model on. So the pre-training tends to take almost a week's time for us, whereas the fine-tuning tends to take almost 3 days for us, right? And what you're basically trying to do is that during the inference, or when you're running the model, you basically have the same thing, but you don't have the target, right? So when you're training the model, you're basically showing it the right answer, but when you're actually calling the model during, when you're trying it in the IDE, you're not giving it the answer. The idea is that you've shown it enough pairs of left-hand side, right-hand side, that has now figured out that even if you don't tell me the right-hand side, I know what to predict, right? So that's basically the idea behind training a machine learning model. Our entire training happens on a Rhodes cluster, so Red Hat Open Data Science cluster. So it's a Kubernetes and an OpenShift cluster. What we try to do is we basically run the whole ML workload on these clusters, so including the pre-training that we do, the fine-tuning that we do, the data preparation that we do. And the reason why this is very interesting to us is basically going back to the same thing. So the reason why we think this is interesting is because this foundation model while we are starting with prediction of what the task should be, so if you give me a prompt, can I generate what the code is going to be? You can leverage the same model to understand, can you explain this code to me? Or can you optimize this code for me? Or similar to Ansible, can you show me an OpenShift? So if I tell you, deploy me a pod with 3 replicas, can I answer that question? So the idea with these foundation models is that we don't have to train individual models to sort out all these things, right? The idea is that while we are starting with Ansible as a use case, the idea is that with the same foundation model, we'll be able to answer all these other questions as well. And those are the things that are still work in progress. But OK, you've trained your model, great. But I guess the question that gets asked is, how is this different from ChatGPT? ChatGPT does this. Or there are other 15 technologies that does this. I guess the biggest thing for us is basically, the reason why we think it's different is because we are very much Ansible focused, which means that we have to figure out what exactly is the right answer in Ansible, right? So if I basically give you a question, how do you even say that this is the right answer? This is code, right? You can write a code in a different manner. I can write a code in a different manner. We can all try to solve the same problem, but write different code. So this is where I think what we're trying to figure out is, how do you even say that when we're training the model, what a right answer looks like, right? So for example, this is a prediction that the model made, and this was the target, right? So this was actually the ground truth, or this is what the right answer was supposed to be. Right? How do you even say these two, this answer is right or this answer is wrong? Or how do you say that the other way around? So what we've tried to do is we've tried to figure out or work with Red Hat to find out a few ways to do this. Again, to us, this is work in progress, and that's why we feel that we're not done. Right? So that's why it's going to be an evolving technology. So the simplest way you can say something is right or wrong is whether you got the package name right or whether you got the module name right or not. Right? So you're basically saying install the latest version of Apache. In both the cases, in one case you're doing yum, in one case you're doing DNF, right? Well, both are right. So I think the biggest one for us is basically, can we get the module name right or not? So that's the biggest boost for us. If we can get the module name right, that means that we've done a good amount of our job, right? The second one is, well, there's a bunch of keys over here, there's a bunch of keys over here. Well, is this really bad for us to generate this part? So this is the second part, right? That are you getting all the required keys right or not, right? Are you generating all the required keys that are needed, and whether you're getting them right? Similarly, if you're generating optional keys, whether those optional keys are harming you or they are not, they're not going to change the answer so much. So there's a bunch of ways we are trying to figure out that how do we predict a right answer. And this is where I think it's work in progress. So we have started with a few of these metrics that we are trying to figure out that whether we're doing a good job or not. And the idea is that we'll keep evolving to figure out better and better metrics. So as you basically try this out, and as you sort of accept, reject, change your answers, and give us feedback, that's how we basically are going to learn that what a right answer is going to look like. With this, that's pretty much it. And I'll go ahead and invite Robin to take us through.
I think I'm.
Oh, thank you.
So Atin made a great comment there. We also used a simple calculus when talking about the experience. So anybody, high school senior or above. No, I'm just teasing Atin here. All of that hard machine learning work doesn't do much good without providing both an outbound user experience, which is what you've seen demoed already. How do you type in a request into this system, get a response back? But the majority of the value to make this better is actually happening under the hood, behind the scenes, when you actually use the system. What's right, what's wrong, how do we feed that data back into the platform? And so what we've been doing with the VS Code extension is to create an experience that is seamless for our developers, for Ansible users who are already using the VS Code extension. It's old hat. You just use the extension like you would normally, and now you have this capability to type in a name prompt and a recommendation, what will happen. But we also want to be able to provide you the capability to tell us when things are right or wrong. Just like Atin was mentioning in the example kind of pulled out of the context of VS Code, we wanted the ability to provide that experience within the editor itself. So we've started to bake in those capabilities into the extension today. If you sign up for the closed beta, or if you start to use the open technology preview next month, there will be no change in terms of, from an experience perspective. This will just be baked into it. And what that will allow your participation to do is help contribute to the improvement of the model over time. We also have worked with the IBM team to do more than what was just described on the previous slide, which is use post-processing. This is both IBM and Red Hat expertise, which, for instance, takes a recommendation that may not have a fully qualified collection name and convert it into a fully qualified collection name. So we want to use Ansible best practices and augment machine learning recommendations with tooling that, again, from your perspective as the user, will be entirely transparent. But what you get is the right recommendation at the end. The model makes a recommendation. Ansible's technologies make sure that that recommendation aligns with best practices. Then that best practice output is delivered to you as the user through VS Code. So I didn't hit on this a little bit, but right now we're focused on task level suggestions. The prompt, so the prompt is what you type into a name, right? This is, I want to automate something. I want to do something. What happens when you type that in is everything prior to the prompt is considered as part of the recommendation. So this, in this very simple playbook, right, it's just the header content for the playbook itself. But if you had multiple tasks, everything prior to the task you're actually working on is called the prompt. Or I'm sorry, that's called the context. The prompt is the name. Then you get the recommendation, the output, and you can accept or reject that. And leaning into what I was just mentioning in terms of the feedback model, whether you accept or reject something using the VS Code extension tells us a whole lot about whether or not this was a good prediction or not. If you reject it outright, we probably gave you something that was entirely wrong, and we need to improve on that. So behind the scenes, we've got an indicator that we're making an incorrect prediction based on create EC2 instance if you happen to reject that. Of course, if you accept it, that also tells us, hey, this is either really good or it's good enough for me to start editing it, and I can use it as a template. And as I mentioned earlier, that's really our sweet spot. Like, we're not going to get a lot of these predictions right because language is hard, and understanding variable context is hard. But what we can do is understand, as people use this solution over time, understand the patterns by which recommendations are made and edits are made to come up with better predictions over time. And since this is all specifically targeted toward Ansible, we believe we'll be able to accelerate that improvement at a much higher or a much faster rate than other options. And you don't have to do the context switching, hopping between browsers and your IDE. This is happening all in VS Code. So if you're already in VS Code, there's no context switching, and it's all happening right there. So it should be faster for you to build out your automation. So Matthew Jones hit on our content matching solution. You may hear of it referred to as attribution, but really it's content matching. So when we make a recommendation, we also want to be able to recognize the contributors of Ansible content as part of this solution. If you're a contributor to Ansible Galaxy, then you're already publishing your content out there for others to consume. You've either a desire to share the work that you've done, or whatever your reason is for sharing your content. But if that content is being used to train a model, we want to make sure that we can identify the people that are contributing and account or give them recognition for their contribution to the Ansible community. And we think that this feature right here will be really helpful in determining the source of a recommendation. Because with this information, I can go to this Git repository now. Like if I understand that that this collection is giving me a lot of recommendations that I'm using, well, maybe I need to explore the roles that are baked into it, and I can reuse that in different business processes that I'm not even writing. So it gives you the opportunity to discover a whole lot of content you may not be using already. And one other important part too is licensing, right? So if you're working for an organization, not just writing personal automation, you're probably considering the licenses for pulling automation from anywhere, right? Whether it's Galaxy, GitHub, any other source. What we want to do is be as open and transparent with you as the user regarding what content we've used to train and what the license or licenses of that content are. And while we can't say with absolute certainty that a recommendation came from a particular source because of all the complexity Yatin just mentioned, right? It's making a prediction based on what it has seen, but that may not necessarily be exactly the entire source of a given prediction. So we do have, we call it content attribution because we think it's the closest match between source and recommendation that we can make. And we think that'll be really valuable for our users here. All right, now Robin's going to give a little demo.
So I will do, there we go. I'll do my best to keep it interesting for you. So I'm acting as the novice automator that Scott talked about. Sure. How's that? Better? Good? A little bigger?
One more.
Here, why don't we do this, do that. How's that? Good?
Is that okay?
Okay, awesome. So I'm a novice automator. I am tasked with standing up WordPress on an AWS EC2 instance. And I'm new to Ansible, so I don't know much about creating this playbook, but I do know the manual steps that I need to take. So I've gotten as far as stubbing those out into this playbook. So that's what you see here, kind of my skeleton, what I need to do. So I'm really hoping that Lightspeed's going to help me identify the modules that I need and the parameters required to get my job done. So let's give this a try. And you can see in the bottom right that Lightspeed is engaged, and it's already given me my first recommendation. And that module looks promising from the name of it, and I can see it recognized that I said I wanted to name this the VPC WordPress, so that looks great. It's given me a placeholder for my CIDR, so let me go ahead and fill that in. State present, and let me give this a little bit better variable name. Cool, this looks awesome. So I'm going to keep moving on. The next thing I need to do is create a security group for my VPC to allow SSH and HTTP traffic in. And I got my second recommendation. That looks promising again. Now here I didn't say what I wanted to call it, so it named it named it AWS. I'm going to name it WordPress. And let's see, it gave me a reasonable description, but I'm going to go ahead and update that. And I can see it actually was smarter than me and sensed that I wanted HTTPS support and added that to the rules. So I've got the 80, 443, and 22. This needs a little update, but that's okay. It gave me most of it, so easy to fix up. One thing that it didn't do that I would have loved to have seen, but maybe over time will get better, it did not notice that I would have wanted to use this WordPress VPC variable here, so I need to put that in place. And it gave me an awesome tag that I do not have use for. I'll get rid of it, but that's cool that it showed me how to create a tag if I wanted one. And it gave me an awesome variable name that I'm also going to replace. Security group. All right, that's looking good. So we'll keep going. Next, we're creating our internet gateway for the VPC. And in this case, we can see it's picked up from the context from the prior task where I had the VPC ID parameter. It's actually now recognizing that and using the same value here, which is awesome. So this is pretty much perfect as is. I'm just going to update the variable name. And we're going to create our subnet. This looks good too. Again, it's got my VPC recognized. And then let me just update that guy. And so it's given me AZ, and let's see what that is. If we hover over it, I can see that's for the availability zone. I don't actually need that. I'm going to take it out. I'm going to let AWS choose for me. And again, it's given me a bunch of resource tags that don't mean anything to me, so I'm going to take them out. But at least I would know how to add them if I wanted them. And we'll update that, stay consistent, and create the route table. And I'm hoping that it's going to recognize I want to use my subnet and my gateway in this route table. And actually, it looks like it did an awesome job. It picked up my VPC, picked up my subnet, picked up my gateway. So this actually looks really good. And I'm ready to create my EC2 instance. So I'm looking for a T2 small. And I'm going to name it WordPress and put it in the subnet that I just created and assign it a public IP. So I got my name correct. I'm just going to grab my AMI ID from this comment and move it in here. It got T2 small correct. So it did not get my subnet. I would have liked to have seen it magically knowing that I needed this guy. So that's another spot where we could continue to improve. And same with the security group. Where is that guy? And in this case, too, I would need to know that the key I'm looking for in here is group ID. So, all right, it's got my public IP, perfect. This volume I don't need, I'm going to take it out. And let's hover over count and see what that's for. Number of instances will always launch a new. I don't think I want that, so I'm going to take that out. And then one more thing I know I need is my key name, which it prompts me for, which is cool. And I want to make sure that it's running, so I'm going to give it a state. And let me see what the choices are. There's one called running that looks good. Awesome. So that's it for my first play. That's going to go ahead and create that EC2 instance. So now we can move on to actually standing up WordPress. But one thing that I needed to do, and you'll see in here, I cheated and hard-coded this task because try as I might, I could not get Lightspeed to give me a good suggestion for this particular prompt. And as you're playing with it, you'll see just changing up a couple of words can make a pretty big difference in what you get back. And so if you're not seeing a parameter you need, you can try tuning it a little bit. But I could not get a good answer for this one. Room for improvement, so it's hard-coded for now. So, and this is just to set up actual WordPress. The first thing we do is wait for the connection. That looks perfect as it is. I need to install my packages onto the EC2 instance. And let's check those over. It's pretty awesome. It's got the package module and all four of the things that I need to install. And now we need to download and unarchive the actual WordPress source. And that actually looks good, I think. And actually, I've gone sideways somewhere because this did not fill in. Hold please while I follow my cheat sheet. Here's the answer key. Let's just grab that. So that would need to get filled in. And then I need to update the owner of the folder that I just created when I unzipped to Apache, and that looks perfect. And then I just need to start up my services. And that looks perfect too. Okay, awesome. And then I had one more play in here just to grab the public DNS name of the EC2 instance. So with that, I have my whole playbook. I'm a little terrified to run it because something is slightly different from when I ran through this before, but we're going to run it anyway and see what happens. Live demo fun. And while this is running, I do want to jump in and show you all the training matches that Scott was talking about. So you can see here, every time that you get a suggestion back, when you tab to accept it, you'll see that this panel refreshes with the top 3 matches. And this is using a k-nearest neighbor algorithm to decide what's the closest match to the content. So you can see the links out to Galaxy, and you can jump out there and take a look if you want. And I can see that something has failed. WordPress instance is undefined. What did I do wrong, guys? I don't know.
Well, we can probably try and troubleshoot that.
Yeah.
But
yeah.
the good news here is that this is actually showing the importance of having an editing process and a review process, regardless of the generative AI that you're using, right? And so what we hope that this actually demonstrates is that there's some things that this solution can do really well. It can help you templatize and get started really, really quickly. There are some, Robin even had the hard-coded task. The model just hasn't seen enough of those types of descriptions and responses from those descriptions in all of Galaxy and GitHub and everything else that our IBM friends are scanning in order to make a quality prediction there. And I'm sure you all will have many of those types of use cases. But through the use of the solution, through Robin's development of this playbook, we'll be able to take that telemetry back and understand how she tweaked the responses from those prompts and develop, fine-tune the model again so that it can have a response for that the next time you write the playbook.
I think I found it, but
Found
you never
it?
know. You never know. You can keep chatting just in case.
Well, while we're waiting, oh, it's still.
Yep, still bad. What?
176 is server, not instance. Yeah.
Oh,
And 983 needs to be predicted.
thanks, guys.
See, we've got
Look at
our
this. Open
Ansible
source
experts right here to help out with the novice user.
Yeah, that's right, guys. That's exactly right. Did I have another problem in here too, while we're all troubleshooting?
So I'll kind of jump into since we're going to start to run short on time here. While Robin's playing this out, let's talk about what the future looks like. So as I mentioned earlier, starting in June, we're going to open up this service to technical preview. Anybody today can sign up for our closed beta. So if you're interested in participating, getting your hands on the system, we just basically need your GitHub ID and your email address so we can communicate with you. And onboard you, we use GitHub as the identity provider for the solution. Other than that, you can get access and start playing with it today. If you don't want to do that, June 20th or 22nd, don't hold me because I can't, but that week in June we'll open it up and anybody can have access. That will focus on task level generation like we've shown you today. As we move toward the fall, and our commercial offering, we want to bring a number of different features that can enhance the Ansible experience. One being something like a Dependabot style experience, so you can attach your your Ansible content that you've had around for years, and especially for orgs that are in the process of moving from AAP1 to 2. We want to be able to give you the ability to point a bot at your old code and make predictions like this for how you can modernize it. Because we're not going to predict AAP1.x Ansible content with Ansible Lightspeed. We're going to focus on predicting modern active content paradigms. So, and we think that this Dependabot will both help you in any kind of migration today, but also in the future, right? You can set it and forget it, for lack of a better way to put it there. And we'll submit PRs to your existing code when we see there's an opportunity to improve it over time. We also want to expose entire playbook level generation. So instead of focusing on task, how can you write out in natural language? What we're trying to do here is differentiate between your chat GPTs and an experience like this. How can we give you that capability within the code editor as opposed to you having to open up your web browser and type in a natural language sentence? What can we do for you within Visual Studio Code or your editor of preference to make that process more seamless and so you get the output that you want at the end of that recommendation? We want to be able to deliver REST APIs so that you can integrate other editors, your CI/CD processes, anything you can do an integration with. We want to be able to offer this type of capability to you through that type of vector. And of course, we've got a number of different capabilities we want to bring over time too. One other thing I'll mention really quickly is the VS Studio Code extension will have an update in the next few weeks with the, oh, now I can flip over. Okay, cool, you already had it up there. So I hit on these. Other interfaces as well are important to us too. So we do want to bring a web-based experience and other code editors over time if we can. But we need your feedback there. We need to know what's important. If we get 2 people that say I need Vim and 2 people that say I need Emacs, that doesn't tell me a lot about where I should invest our time. So with that enhancement to Visual Studio Code though, you'll be able to provide feedback regarding the recommendations that you get, regarding enhancements to the product that you would like to see, including like what I just mentioned. Hey, Visual Studio Code's great, but I don't use it. Can you guys do something else? That is all information we would like to hear. So please feel free to use it in that regard. The more usage we get, the better this improves over time, because we'll have both the usage data and that type of feedback data. So we've got about 5 minutes left. Are there any questions? And please feel free to ask Lightspeed. Oh goodness. And the AI questions, you've got an AI expert here. We'll also stay afterward too, so we've got more. We'll go first.
I have one
Sure.
just a concern that I have about training. You could overtrain or you could mistrain, and it seems like it might end up being almost like a user education thing. But to use a metaphor, Pandora, they came out and you say like, okay, you can build a radio station. Give me songs that are like this one. Everybody who I know said, I like this song or I don't like this song, not yes, you're going in the right direction. So they ended up with stations that were trained based on whether they liked things or not, and it just gave them a bunch of random stuff. It didn't end up being really on target. Do you see that as a risk, or do you have a thought about how you're going to mitigate that?
So, do you want me to hit that or do you?
No, go ahead.
Okay, so there's always a risk, right? Like we don't know what we don't know. And to Aten's point, the generation of a machine learning model results in something unexpected every time our 2 teams collaborate on it. And so what we need to be able to do is get feedback from our users that say that pattern is happening. We're seeing a circumstance start to manifest that doesn't meet my expectations. I want to see, for instance, AWS module responses when I talk about cloud use cases in my model. And so we want to be able to train the model at a generic level to understand as much as we can, but then also through IBM's capabilities, give your organization the ability to fine tune different models that are unique to your organization so that you can set those types of preferences at different granularity levels, per user, per org, per group, whatever. And it will ultimately be a combination of both IBM and Red Hat's experience and the machine learning side to make that, to overcome that kind of problem.
Yeah, that's good.
Okay. Okay, so I'm going to get somebody in the back. I'll come back. You, sir. If you come up afterward, I'll give you the link and I'll send it to you. It's not an easy one. If you Google Project Wisdom, Project Wisdom will be the second link that returns in Google. That's the easiest way to do it while we're in the room right here.
Ansible Lightspeed. Just Google Ansible Lightspeed.
Either will work, but you'll end up on this page.
Yeah.
Now, the web team actually broke our sign-up link earlier today. I'm waiting for them to fix it. So I hope it's back in there right now. It should come back later today. So yeah. Yes, sir. I know you had a question.
Offline environments, will this be available in air-gapped frameworks?
So we're exploring that, but our first approach here is going to be, a SaaS-style approach like we've got here. With an air-gapped circumstance, we're talking about both the machine learning technology, so OpenShift AI, the IBM Watson Code Assistant technologies, and the Lightspeed technologies. And we're actually, to be frank, we're assessing how we actually would execute that and bring you that kind of product right now. It's absolutely on our radar. I don't have a timeline for it. Yes, sir.
Recommendation thing where we say that, okay, we accept this. So after some time, let's say I run it, I figure out that there's something wrong, then I can fix it. Will it be able to go back that, okay, that recommendation I actually don't accept?
So we are able to detect that you accepted something and that you changed something that you accepted. And so we'll be able to infer that we gave you a recommendation, Because we know from the model, right? The model gave you this recommendation. We know that you accepted it. We'll know that you changed it, and then we can basically create a diff between the two to see how you changed it and learn from that.
And that change has to be the same person in the same session doing
Correct. Yes.
someone else changing it.
Exactly. Yeah. Yeah. So all of this is within the context of the IDE as it's operating. Yes, sir.
To something that follows on to that point specifically, I was thinking that really the most interesting thing to you might be was the PR eventually accepted a merge. You know, that's the moment where someone definitely went, that's good code. Because I write all kinds of junk. And it's not until it gets to a merge, that's when I'm like, I'm actually genuinely happy with it. If you haven't got visibility, that's a shame. It would be great.
No, that's a great point. So and Atin might be able to help me with an answer here too. So we'll actually explore what our options are there. The one thing that's kind of spinning through my head, if we move out of VS Code, then we would have to figure out how to hook into Git and understand like where in the flow that event actually happens. But we're obviously training the model on Galaxy data and GitHub data, and if that content is in the repositories that we're already training on, we would ultimately see that change. So good suggestion. I think we've got some idea there to noodle on a bit. Yes, I'll come to you next. Okay.
I saw that we're looking at creating playbooks in the future. It sounds like that would go into roles at a later time. You guys are planning on doing collections even?
Yeah, well, so task-based generation will help with roles now too. You don't have to be in playbook syntax, but we want playbooks. We want playbook recommendations to be as aware of roles as possible. So if a role exists that you can pull in, there's no point in generating a playbook with 20 tasks when a role will do that for you. So that's the kind of role-based context we're looking at right now. But going into developing roles, we're also exploring that, but a little bit higher level. What does it actually mean? Do you need help framing the structure of your role or collection projects? What would be of value if you were to ask the AI to generate something for you there? What beyond just the task level generation would you ultimately want from it? Those are all questions we're actually asking right now. So if you've got suggestions, I'm all ears.
Do you feel like this will help you onboard modules or vendors faster?
I actually don't know the answer to that question, to tell you the truth. It might, especially depending on whether or not that module is used heavily within the organization, and if that organization has a preference for tuning the model for that module over time. In those circumstances, absolutely. But depending on the size of the org, module development can be either really tedious and something highly invested in, or not at all, right? You might just use stuff you find in the public domain, and so, yeah. I missed you. You sure? Okay. Yes.
So this is trained on all the collections in Galaxy?
Yes, but if you use Ansible Galaxy and you would not like your data to be part of this process, there is an opt-out mechanism in the new Ansible Galaxy that is currently in beta. So you can opt out. We would obviously like for you to participate, but that option is there.
Asking, like ChatGPT will literally make up collection names that don't exist.
Right.
Your recommendations will actually all.
Well, not necessarily. I mean, IBM's got processes for generating data to help train the model.
Yeah, so that's the differentiation, right? That's where I think us specializing on Ansible, that we're not just making up things just for the sake of making up things. So this is where I think the evaluation that we do, right? Like we're not just generating random stuff. Like we're generating valid Ansible, valid YAML. It's gonna, with valid keys and everything. So that's the work that we are doing, and that's why we think that that's the differentiation to the ChatGPTs.
Cool, thanks. I guess the thing I was wondering about now too, but one is it possible potentially to hook it up so that it could get the feedback from Playbook, for instance, like say, okay, that didn't work.
Like the output of running the playbook?
Yeah, like I guess to Benedict's point was, as you open it up to people who are potentially not the greatest Ansible people in the world, you're going to have an influx of people who can't write any code. They may shift all this, like saying, oh, well, you've accepted your crap Ansible, that doesn't work, and it might, make it less valuable.
So what the ultimate solution is, I can't say, but what I can say is that we are looking at that very problem and solving it through a combination of things rather than just the playbook output. So Matt's demo yesterday on the stage, focused on using Ansible lint to visualize the fact that something, wasn't a best practice. So we'll lean heavily into the post-processing tools that come after even what I talked about as part of Ansible Wisdom, leaning heavily into lint and other tools that we're building to ensure that whatever the best practice is, it can be applied to the playbook at development time as opposed to runtime. But that doesn't preclude collecting more data because, as Atin mentioned, the more data we have, regardless of the shape of that data, it helps improve the model because we know more about it over time.
So, just watching what Robin was doing, is it able to learn that she was prefixing registers?
Yes.
Went down, because it obviously wasn't doing that.
Yeah, it actually picked it up toward the end too, and I should have called that out. It did, one of the later ones, it did pick up the WordPress, whatever.
And this is where we think we don't have a final product, right? This is still work in progress. The idea is that, once we start seeing enough of these patterns, the idea is that we should be able to figure out that, okay, you've registered something, it needs to be picked up. So that's where I think the improvement is coming, yeah.
Right, and like this too, right? I assume we just need more examples, and
Yes.
it will do better with what we're
Yeah.
trying to do here.
Yeah.
I think the other thing I was thinking about as well was if you do get the output, potentially you could start doing templating. Because just do playbooks, you can't tell whether your agenda is going to actually be.
So all of those questions are absolutely valid, and we would, again, it would be great to get you all into the system and using it, because that type of feedback that we're going to be able to collect, especially when the VS Code extension comes along, that'll tell us exactly the types of issues that you're hitting with this, and will help us knock them out quicker.
Exactly, like there's feedback that we can learn by looking at the patterns and how it's being used, but like explicit feedback that you guys provide, right? Okay, this is not working, or this is working, or this is what we like, this is what we don't like. That's like a big boost signal to us, right? We know what the right direction is to look in.
Yeah, so that's a great question. Yes, the file that you're actively working on is uploaded because that's the context in which a recommendation is made. However, and just a general comment on data sensitivity before the however, if you have sensitive data that you know you're going to write into your playbook, don't write it into the playbook and use an AI system. Whether it's ours or any, you're sending that data to a third party in any case, and if it's sensitive, you should treat it as sensitive data.
My comment about that is that the people in this room probably know that, but a lot of people out there don't know that.
You're absolutely right. So the however is we are baking in ingestion processes along with the post-processing to help mitigate the fact that anybody could send that data. So we're scanning for common PII patterns for any type of string pattern matching, things of that nature, that we can avoid capturing any data like that. But no system is perfect, so that will happen ultimately. And our intent is to have processes in place to remove it if it happens. And
Is that happening in the extension?
it is the collection of the information happens in the extension. Some of it will happen in the extension, but a lot of it happens once it's already sent.
Would there be a way how to tell the extension not to read parts of the file, for example?
That's an idea we haven't necessarily explored yet. Like maybe we could have some sort of metadata or tagging mechanism in the file to do that. I think that's a great idea.
Yeah, that's a good idea.
Yeah,
Yeah.
we'll look at that. Excellent. Yes, sir.
Question, does it give you a list of like sources where it found the information like you got on the screen right now? Does it print that into the repo or something where you could have sort of bill of materials where it got the sources from?
No, but that's a great idea too. Yeah. No, that's fantastic. Yeah. Thank you all very much. We're a little late.
Thank you.
Really appreciate it.
Yeah, thank you.